This lesson is on the elimination method, also known as the addition or subtraction method, sometimes referred to as the combination method, of solving a system of equations. So the steps here are to line up our variables, right? So x is lined up with x's, y is lined up with y's. Get them so at least one of them has the same coefficient, either the x's or the y's, and remember this doesn't have to be x and y, it could be p's and q's, a's and b's. And then and then we either add or subtract the two equations so that they cancel out whichever one of those ones has the coefficient that matches. We then solve for the remaining variable that is left over. And then the last two steps are just the same as when we were doing the substitution method. We take our answer for the one variable, plug it into an equation that we started out with, and solve for the other variable. Don't forget to check your answer. So we're going to go through a few examples here. So our first one, we have 2x plus 3y equals 12, 2x minus y equals minus 4. So our 2x's already match up. So what we want to do with this is get those ones that match up to cancel. So since they both have the same sign, we're going to subtract them. And most people find on these questions that it's easier if we do the subtraction, show that we're changing the sign of everything. So I'm going to keep them lined up. I'm going to go 2x plus 3y and keep that equation exactly like it was. But the second one, I'm going to change the sign of everything because I'm subtracting it. So 2x becomes negative 2x, negative y becomes positive y, and negative 4 becomes positive 4. Now I can add these two equations. So I end up with 2x minus 2x cancels, so that's 0 if we do want to write something there. 3y plus y gives us 4y. Negative 12 plus 4 gives us negative 8. So we can solve that equation by looking at by solving for y. So 4y equals minus 8, we just divide both sides by 4, so y equals minus 2. Again, Word wants to change my capitalization. So we have y. Remember, these aren't solved until we have the answer to both variables, so once we know y, we can substitute into either equation. So I'm going to substitute into the second equation. It really doesn't matter which one you pick. So when we get that, wherever we've got a y, we are going to replace it with 2x minus 2. Right, so the y value is minus 2, so where we have a y, we're going to put in minus 2. This leaves us with 2x plus 2 equals negative 4. So we can bring that over. Scroll up here so we can see the whole question. So 2x equals negative 6. X equals minus 3. So our solution, negative 3, negative 2. So like with our other algebraic method where we were using substitution, we should check the answer in at least the equation we didn't finish off with. So since I finished off with the second equation, I'm going to check in the first. So we get 2, actually let's write the whole equation, 2x plus 3y equals negative 12, so plugging our values in, we get 2 times minus 3 plus 3 That's minus 2 on the left side, negative 12 on the right side. Remember, on these equations, we keep things on the side that they're on. So we won't move anything over. We're just seeing, does the left-hand side equal the right-hand side? And in fact, we do get minus 12 equals minus 12. So the solution is correct. Okay, so that one we already had our x matching up. What do we do if the x or the y doesn't match up? Here we have 1x, 1y, and 3x, and 2y. So nothing matches. So we need to make one of them match. And in this case, I can multiply my top equation by 3 if I want my x's to match, or I can multiply my my top equation by 2 if I want my y's to match. So I'm going to pick the 2. So I'm going to take that whole equation and I'm going to multiply it by 2. Be careful with this. You need to remember to multiply both sides. Common mistake is missing one side or the other. So if I'm multiplying x by 2, I get 2x, y by 2, I get 2y. And don't forget the 3 times 2 is going to give me 6. And also don't forget the negative. So my other one, I have 3x minus 2y. I'm going to keep that. And so now I can add these, and this time I'm adding, not subtracting, because I already have opposite sides. Right? The negative 2y and the positive 2y are going to cancel when I add. Really need to have my... There we go. So 2x plus 3x gives us 5x. The y's cancel, so we could show 0 again, but we really don't need to show the 0. We can just say 5x equals negative 10. So divide both sides by 5. We get x equals minus 2. Once we have our x, we can substitute into either equation. So I'm going to substitute into the first equation. Actually, let's just take that equation. So I take my original equation, not my multiplied one, because it's a little bit simpler. And wherever I have an x, I'm going to put in the minus 2. So this part's pretty much the same as our other method. And since I've got minus 2 there, I'm going to bring it over, make it positive, so y equals negative 3 plus 2, which is going to give us y equals negative 1. And from there, we can do our check again. Actually, let's write our solution first, what we think our solution is. So in this case, it is minus 2 comma minus 1, because our x was minus 2, our y is minus 1. So let's substitute that in. So the last one we started with second equation, so we're going to check in the first equation. Sorry, we're going to check in the second because we just did the first equation. So 3x minus 2y equals minus 4 becomes 3 times minus 2. Subtract 2 times minus 1, and we get minus 4. So let's see if that works out. So negative 6, and then we have a negative, times a negative, so we get positive 2. And negative 6 plus 2 does in fact give us minus 4, so our solution is correct. Okay, the next couple, we're going to keep going on with this. We're going to do 2 more examples. So with the next one, we have 2 issues. One, we've got fractions, and 2, our x's and our y's aren't lined up. So it doesn't matter what order we deal with those 2 issues, but we have to deal with both of them. So I'm going to, first of all, multiply by 3 on this second equation so that we can deal with those fractions. So that gives us 3x equals 2 minus 1y, or just y. On my other equation, I'm just going to bring it forward. So not going to change anything about that. Well, they still don't quite line up. I need to bring my y back to the other side. So I'm going to take this one and I'm going to rearrange it so that my y's line up. So I get 3x plus y equals 2. And my other equation, I can actually just bring it over even further so that these line up. Now I can see what's going to happen here when I subtract these, and to subtract them I can just change the sign on everything here. We end up with everything canceling out. Or in other words, we get 0 equals 0. Now that's true, 0 does equal 0, but it's not helpful. So we say this is true, but it doesn't determine our solution. Now earlier on in the notes we had talked about how when we have a system of equations we have 3 scenarios. Either 1, they're the same equation and then you have infinite solutions. 2, they meet nicely once at one point of intersection, in which case we have a single solution. Or 3, they're parallel lines and they never intercept. So this 0 equals 0 tells us we have one of those situations where they don't just nicely cross and we have one single solution. This is the one when we end up with a true solution that tells us nothing, like 0 equals 0 or 2 equals 2. It tells us that we have the same line. And in fact we could see that right before I did the subtraction. They looked identical. So we knew they were the same line, and consequently we don't have a single solution. So remember, on those ones where we have the same line, there's several ways we can write that. We can say there's infinite solutions, and feel free to use the infinity sign for that. And that is because they are a dependent system, which means they are the same line. So any one of those 3 things would tell you would be a correct way of showing the answer for one like that. Okay, the next one, the last one of the examples that I plan on doing on this video, we have x's that don't match, y's that don't match, and I can't just multiply one of my equations. That won't make them match. So I either need to get a common multiple for my x's or for my y's. It doesn't matter which you pick. So we can either multiply to make both the x's 10, or we could multiply to make both the y's 6. I think I'm going to go with the 10 version, get my x's canceled out. So I'm going to multiply the top one by 2, and I'm going to multiply the bottom one by 5. So when I do that, let's see what we end up with. And in fact, I'm going to pick -5 so I automatically have opposite signs here. So I'm going to get 10x plus 4y, don't forget to multiply every term, equals 10. And on my other one, I'm going to get negative 10x minus 15y equals minus 65. So I'm going to take those, I'm going to add them up. So my 10x and my 10x cancel. I'm left with negative 11y equals negative 55. Divide both sides by negative 11. We get y equals positive 5. Once I have my y, I can substitute into either equation. So I'm going to substitute into the first. So that gives me 5x plus 2, and substitute my y value, so put in 5 equals 5. So that's going to give me 5x plus 10 equals 5. Subtract 10 from both sides. And we're going to get 5x equals negative 5. So x will be negative 1. And from there we can do our check. So I did my last step in the first equation. I'm going to check in the second. I should write my solution first though. So my solution is x is minus 1, y is 5. So when we check that in our second equation, we're going to get 2 times minus 1 plus 3 times 5 hopefully equals 13. Minus 2 plus 15 equals 13. And yes, in fact, we get 13 equals 13. So the solution is correct. So be careful with a couple things on these questions. Common mistakes when you multiply, missing one of the two, or one of the three terms. Make sure your x's line up with your x's, your y's line up with your y's, and your constants line up with your constants. And do check your answers. Don't freak out if you get the weird scenarios for the dependent system or the inconsistent system. Quick reminder, didn't have any examples on these ones that had inconsistent systems, but the inconsistent system, instead of getting something like 0 equals 0, we'll end up with a false statement like 0 equals 2. So if you find yourself getting a false statement, that tells you you have parallel lines. And again, you can check that by making sure they're both in the same form. Usually we try checking them by putting them both into slope-intercept form so that we can see what their slope and their intercept are. If they have the same slope and the same intercept, they're the same line. If they have the same slope but different intercepts, they are parallel lines. So that's where we're going to pause this one before we have another video on word problems.